Welcome to the DIY Honda Garage channel. Today we are discussing DTC P16F3, which indicates a low voltage in the starter cut relay 1 control circuit for the 2023 Plus Honda CR-V. This diagnostic trouble code, or DTC, is crucial as it directly relates to the vehicle's starting system. If the signal returned from the starter cut relay is low when the vehicle's starter is off, the powertrain control module, PCM, records this fault. The PCM essentially acts as the vehicle's brain, monitoring various systems and ensuring they function correctly. We will go through the components involved, the likely causes of this issue, associated symptoms, and a detailed troubleshooting process step by step. By the end of this presentation, you should have a solid understanding of how to diagnose and address DTC P16F3 in a Honda CR-V. DTC P16F3 pertains specifically to the starter cut relay 1, which is responsible for controlling the starting function of the engine. The starter cut relay manages the current supply to the starter motor, ensuring it engages when required and disengages when not in operation. A signal is returned from this relay to the PCM, which constantly monitors its status. If this signal is found to be low, with the starter in the off position, the PCM flags this as an abnormal condition, thereby triggering DTC P16F3. The significance of the PCM here is paramount. It processes information from various sensors and actuators throughout the vehicle, delivering accurate feedback on engine and electrical operations. The location of the starter cut relay is usually in the relay circuit board, which may be accessed under the hood in the engine bay. Identifying these components accurately is vital for effective diagnosis and repair. Several possible causes could lead to the triggering of DTC P16F3. First, a faulty starter cut relay can result in the relay not functioning properly, which would prevent it from sending a correct signal to the PCM. Next, wiring issues within the circuit could also be responsible. For example, damaged or corroded connections could disrupt the electrical signals between the relay and the PCM. Finally, a defective powertrain control module, PCM, itself could cause this low voltage error, as it may fail to process the input from the starter cut relay accurately. It's essential to inspect the integrity of both the relay and the wiring thoroughly when diagnosing this issue. Each of these potential causes requires a different approach to confirm, following a structured diagnostic protocol. The symptoms associated with DTC P16F3 primarily center around the vehicle's starting capabilities. One of the most evident signs is that the engine may not start at all, indicating a failure in the starting circuit. Additionally, a diagnostic warning light may illuminate on the instrument panel, alerting the driver to a potential problem within the vehicle's electrical system. Intermittent starting issues could also manifest, where the engine might start on some occasions but fail on others. This sporadic behavior can be frustrating and often points toward underlying electrical or relay issues. Observing these symptoms critically can help in identifying the correct troubleshooting methods to restore proper vehicle functionality. In the first step of troubleshooting DTC P16F3, begin by turning the vehicle ignition to the on mode without starting the engine. This initial step is critical, as it prepares the vehicle systems for diagnostic testing. Once in the on mode, check the functionality of the starter by attempting to start the engine. At this juncture, determine whether the engine starts successfully or not. If the engine starts, the issue might be intermittent or situational, but if it doesn't, this hints at a more persistent problem. Documenting these observations is vital, as they guide the next steps in the diagnosis and ensure you are approaching the issue methodically. The second troubleshooting step involves inspecting the external circuit associated with the starter cut relay. This means checking connections, terminals, and wiring for any signs of damage, corrosion, or looseness. Proper connectivity is essential for the relay to function correctly and relay signals to the PCM. Pay close attention to the IG1 ACG power supply and the ST-cut RLY1 CL circuit, as these components are critical in ensuring the proper operation of the starter cut relay. Any faults found during this inspection will need to be corrected to eliminate them as the cause of the DTC. Always ensure connections are secured and free of dirt and debris that could prevent solid electrical contact. The next step in diagnosing DTC P16F3 involves testing the starter cut relay itself to confirm its operational state. This can be done by checking for low voltage at its terminals with the ignition in the on position. An ideal voltage reading should be approximately 12 volts when properly functioning. If the voltage reading is lower than this threshold, it suggests that the relay is not receiving sufficient power to operate correctly. It's important to test the relay functionality by conducting a relay swap if possible, or a bench test, to ensure that it can open and close properly under operation. Malfunctions in this component could lead to miscommunication with the PCM, hence causing the low voltage issue. The fourth troubleshooting step focuses on inspecting the connections to the PCM itself. Given that the PCM plays a critical role in processing signals from various vehicle components, it is crucial that its connections are secure and undamaged. Check for corrosion or moisture that could impede performance, ensuring all harness connectors are seated correctly. In cases where physical inspection does not reveal any issues, consider testing the PCM's functionality using specialized diagnostic equipment. This will help in confirming if the PCM is recognizing signals accurately or if it has developed faults leading to the DTC being raised. Remember, an appropriately functioning PCM is essential for vehicle performance. Any issues here could necessitate a replacement or extensive repair. After addressing the underlying issues associated with DTC P15F3, it's crucial to perform final repair verification to ensure everything is functioning as it should. Start by clearing the diagnostic trouble codes from the PCM using a diagnostic scanner. This will reset the vehicle's computer systems and erase the fault codes from memory. Once cleared, it is essential to recheck the system for any codes reappearing, indicating unresolved issues. A test drive of the vehicle should also be conducted, allowing for real-world conditions to verify the relay and PCM are now communicating correctly and the engine starts reliably without any issues. This final step is key to confirming that repairs have been successful and that the vehicle is safe for operation. To prevent the recurrence of DTC P16F3 and ensure the reliable starting of your Honda CR-V, implementing preventative maintenance is vital. Start with regular inspections of the electrical components linked to the starting system, including the starter cut relay and associated wiring. Ensure that all connections are clean, secure, and free from corrosion, as dirt and grime can lead to electrical resistance and eventual failures. Additionally, it is advisable to maintain a schedule for checking battery condition and performance, as weak batteries can impact the entire starting system. Investing time in these small maintenance tasks can save significant repair costs down the line and promise smoother vehicle operation. In conclusion, DTC P16F3 relates to a low voltage issue in the starter cut relay 1 control circuit, primarily affecting the Honda CR-V from 2023 onward. Understanding the nature of this DTC and the key components involved, such as the starter cut relay and PCM, is crucial for effective diagnosis and repair. It's important to follow the troubleshooting steps methodically to accurately identify the cause, whether it be a faulty relay, wiring issues, or a malfunctioning PCM. Additionally, implementing routine inspections and maintenance can greatly reduce the likelihood of encountering such DTCs in the future. By staying proactive, vehicle owners can ensure their Honda CR-V remains efficient and reliable for years to come. Please like and subscribe to the channel. See you next time.